Good morning, everyone, or good afternoon. This is Fred Schenkelberg, and welcome to the webinar today on reliability um, programs and projects. Had a little bit of a hesitation there. I forgot to turn on my microphone when I turned off the music and stuff. So hopefully you can hear me all right. So let me know in the chat window that we're coming through all right. I wanted to spend today talking about kind of a higher level topic of just the project and programs and really what I think of when I think of those terms. But also, what are the challenges and what do we do and how do these two different entities, as I'll describe them in a few minutes, how do they relate? Oftentimes we do a variety of reliability tasks, like say conduct an FMEA study or conduct an accelerated life test, take some prototypes into halt testing. That's usually in context to a project, a product or a service that we're providing, bringing a line up in a plant. But we also do it in context of a larger organization. There's finance and field service and repair teams and development teams and manufacturing teams, procurement, and a variety of other entities within the larger organization that all have to work together in order for a reliability of a product or a process to achieve its potential. So let's step back a little bit from individual tools and techniques and how do these things all fit together? And as I'm getting started here, I'm still having, hopefully somebody can let me know if I'm, use the chat window, let me know if we're broadcasting or if I'm talking to dead air. Still haven't seen anything on that. Also haven't heard any complaints, so that's probably a good thing. But while I'm on this screen, I wanted to point out that there's a couple of pieces of information you should download. If nothing else, get the Reliability Maturity Matrix, which is over to the right of the slide deck here in a downloads area. It's going to be a one-page PDF document. Thanks, Colleen. Thanks, Carl. Appreciate it. Yeah, I haven't started the slides yet. Because I wanted to point out a couple of these downloads is take a look at the matrix and download that. For those that are interested, it lays out the different stages that a company can be in or different levels a company can be in or an organization can be in with respect to reliability. And it goes from, like other maturity matrices, it goes from doesn't know anything about reliability and it just kind of happens to them to very proactive and it's part of their integrated throughout their business. So we'll take a look at that in a few minutes. So get a chance to bring that down to your system. That may be useful for you. And then the other part that's on there, there's slides up there, but also there's a reliability maturity ebook, which is a collection of articles and formatted as a small book. That should be easy to read online or on your screen. But it talks about this assessment process of how do you determine where you are on the maturity matrix. And that may be a useful reference for you. It has way more information than we have time to go through today, but I want to point that out. But it's also part of a series of ebooks I'm working on. There's another one that's up on the Ascendo website. Let me pull up the slides for today. And this is Ascendo Reliability is a website that I host, and I'm planning on adding a bunch of new content to this pretty soon. But the Reliability Maturity Matrix is up here, and the another ebook called Finding Value, which we'll touch on briefly in today's presentation, are both in there. And I'll add the link to the chat window. And if you register for the site, there's a variety of different pieces of information there. and content, but specifically those two ebooks. So hopefully you can find that all right and enjoy those references. And if at any time the chat window is open, so please let me know what you think, or if you've got questions or any of that kind of stuff. So let's talk about a program. And I'm separating program from project, as I alluded to earlier. As a program is how the organization, from the CEO through the entire team, of how you make decisions that are related to reliability. So it may be a strategic directive from the board of directors, or it may be a general manager's policy about how we approach different aspects of reliability, what kind of risks we're willing to take. It may be a directive of how we fund projects, and what do we do, more testing, or we do more analytics, or what information is required during reviews for decision making, for example, would be part of a program. A project is, I want to make a new iPhone, for example. So it'd be a project manager and their team, and they're making a specific project. The reliability aspects of that are basically, what are the risks? What's the goal? What's the risks? What do we know and don't know? And are we going to achieve our objectives? And then how does that fit into the larger organization? Now, if you think about it just briefly, it's pretty obvious that those two things fit together fairly closely. So one of the best ways, for example, to get an estimate of reliability of a project, say the iPhone 6 or 7, I guess now is imminent, and according to the rumors, that using the previous iPhones and their field history would be a reasonable way to get a first pass estimate of the new phone. But we need to talk to people that actually deal with the field returns. And in many organizations, that's a separate organization than the reliability program, or the reliability engineers, I should say, that are supporting a new product development. So do you know, for example, who to talk to get information about what's failing in the field and why? Who's doing the failure analysis? Who's collecting the data? And is it useful for you? And how does that connect? So that's one example of how a program can support a project, and how a project really requires a strong program outside of the particular product in order to get the information they need. And it goes both ways. For example, the finance team really does need to know how many failures to expect during the warranty period, if that's part of your business, or how many spares to stock if you're dealing with a larger asset in a repairs program, because they need to budget for it. So giving them reasonable, accurate information about what to expect is a big part of that communication between a project and a program. So one of the first steps when I'm looking at a project or a program in working with a company, and I've done a good number of assessments. And so that ebook, the Reliability Maturity ebook, and the matrix really started back when I was doing a lot of work at Hewlett-Packard to understand what Hewlett-Packard did for reliability. So we did a whole slew of assessments. But basically, we asked the question, just how good is your program? And for those that pulled down the matrix, let's take a look at that briefly. And let me go back to that again, because this is going to be part what I didn't bother bringing it up on the screen because it's got a lot of information on it and it's really hard to see on the screen. So let me go to where you can find the downloads package, which is to the right of where the slides are. You should be able to find the reliability maturity matrix. Just highlight it and download the file will become available to you. And for those that have it, if you can take a look at it or open it up on your screen, it has 5 columns, or 6 columns, I should say. The first column lists the different topics, things like failure analysis and how do you deal with failures in your fracas system and failure analysis program and so on. The first stage, companies would generally blame somebody for a failure. They blame a vendor, or they blame a designer, or they pretty much ignore the value that's inside of a prototype failure and then drive on. But you can see very quickly across the rows as companies move from improve their understanding of what reliability is and then build deeper and deeper into their programs. So the concept here is that the level one or stage one, I think it is really not all that useful. It's reliability is basically ignored and not really done. And then on the other end of the spectrum is companies that it's built in across the organization. And one of the interesting findings is when I look at the matrix is the levels three or stage three companies uh, tend to do a lot of activities. They have a long suite of tests they run. They have a lot of activities that they're required to do for every checkpoint. It's a very, very busy place. Yet, they're not getting that much return for the investment in it. So as companies move into stage four, they tend to do less activities. The activities they do are focused on adding value for that particular program. And it's at first when we were doing the assessments, we thought that there would be a correlation for the teams that did absolutely nothing. They would have high warranty costs. And the teams that did the most activities would have the lowest reliability costs. Well, it really wasn't true. The teams that did the most oftentimes didn't have time to think through why they were doing the test. They just had 48 different environmental tests they had to do. They had 16 different reliability tests they had to do, and they had to crank out report after report after report, which very few people had any time to read. So it had very little impact. And it was remained in the reactive mode of that when a problem became big enough or was from a big enough customer, they would do something about it. Now, as you move across the stages of the reliability matrix, the overall field failure rate and customer satisfaction numbers improve. They get better. Yet it's a change from reactive to proactive that makes the biggest difference. So let me go back to the slides. So that's what I mean by an assessment. It's really looking at, well, what is your reliability? What is the organization's approach to making decisions? And that's a program issue. It's part of the culture of an organization. It's how you go about doing design reviews is a great place to look at how decisions are made. If it's focused on time to market and feature set and getting the product shipped and very little is ever mentioned about the quality or the reliability of the program or the readiness of the product to meet customers' expectations in their environment, in their use profiles, that's a lower level maturity. Whereas if an organization is integrating reliability discussions into the product requirements document, and it's integrating it into decision making at all levels where it's balanced against time to market and so on, then it really is a different way of creating a product. And many of you may have had experiences in one or more of these different levels of organizations and their types of maturity. So the first three levels, are really levels 2 and 3, is reactionary. I like to think of them as that they make a better fire department. And so I've got the chat window open. Let me know if you are in one of these organizations. It's a reactionary, and you could either raise your hand or enter it into the chat window. If the only time reliability becomes a topic of discussion is when there's a customer failure, that's a classic piece of it. I got a couple people mentioning that. And Jeff, no sound? Am I getting sound from anywhere else? I've got some response to the question I just asked, so I think it's working. But I mean, What I'm looking for here is what's your experience, or have you experienced, I should say, have you experienced a reactionary type organization? You know, the only time you get funding. All right. All right. Got some sound there, Chris. Yeah. The browser sometimes, yeah, that makes a sense. But, all right. How many of you are, you know, in an organization that really does have a, it responds to field failures, uh, and that's the only time that, or the primary time that reliability comes to play. How common is that with this audience? And I'm thinking that this audience is a bit more sophisticated than most because, well, one, you're out there learning about reliability, and this is one of the ways to do it. Yeah, blow up. That's a good term, Rick, to discuss or to highlight how some companies respond or point to it. Hopefully, you're not in an organization that their first response is to blame somebody. Um, and I found a few companies that are pride themselves at being very customer focused. Yet when you look at it, they're only responding to field failures. And instead of using that information and that material to improve the product, they improve the response time. Let's see, a number of people are typing. Yeah, Carl and Greg, both I agree with both of those comments. Um, yeah, duplication of effort. Rick, you're hitting on some of the the downsides to being reactionary. It does take more work at the end of the day. It's kind of that old saying of, you know, penny wise, pound foolish, which I interpret to mean is that, you know, I have time to, if I fix it today, if I adjust the product so that it is reliable and that we have good sense that it actually is going to perform today, we can avoid trying to reanalyze it and redesign it later. Yeah, John, sounds like you're making progress getting into the more proactive side of things. That's great. It's it's exciting to be in a reactionary company, right? The person that solves the customer problems is the leader for a major problem and avoids a recall, for example. They're likely to get promoted. And I like to kid that they're going to get a good parking spot, that kind of thing. Yeah, yeah, right. Good analogy. It's like dieting. Um, it it has to be more than just lip service that we pay attention to reliability, and paying attention to the reliability only when there's a problem, when there's a major prototype failure and it's going to delay shipping, or when a major customer complains. That's generally very expensive and too late to really build in and design in reliability, right? So number one, yeah, Rick, number one in customer support, it's it's not a bad thing. It's just that they shouldn't be very busy. It's easier to be number one in customer support when customers don't complain about your product. Is rather their questions are skewed towards finding new applications for your product and expanding your customer base and using your products to the fullest potential. That can be customer service too. And if that's not part of the mix because it's being crowded out by the just the sheer volume of customer complaints, then you really are in a reactionary type organization. Now, on the proactive side, is we oftentimes don't have, or the product goes through development and we pick the tools that are going to add value. We don't do FMEA if we already know to a great extent what the problems are. Let's say we're doing a product, a family improvement on a previous product, and we're just updating from what we've known from the field data. Well, the field data is a whole lot more valuable than doing an FMEA on the system. maybe focus the FMEAs on the new aspects. So, almost always we add another feature or product or a new vendor or something like that. But it could be a much more diminished role than if it's a brand new technology, brand new market, a big set of unknowns. The proactive teams tend to characterize rather than just test to pass. So if I do a characterization of a set of materials, I can use that information going forward on many different products and thus avoiding doing the testing again. So proactive would classically, instead of doing 85 RH at 85C for 100 hours or 1,000 hours or whatever and pass fail, it would do a test to failure and characterize the failure mechanisms that are pertinent to their product and then use that as a physics of failure model going forward, thus avoiding the repeated sets of testing. But also have a model that allows them to do trade-offs between what the product's capability is, its failure mechanisms are, its failure rates under different stresses, and time to market, costs, and so on. It allows us to enable the design team and the production team to balance decisions so that we have a pretty good sense of what the failure mechanisms are, and we're rarely surprised. Now, of course, systems will fail, products will not work, and customers will have failures at one point or another. That's still going to happen. But in a proactive organization, it will happen on an expected basis. We will rarely, if ever, be surprised by a customer failure. So the idea is in a proactive organization, is that you work to understand how the product will fail and when, and then use that information to make improvements to find the economic balance of what's the right failure level that sustains your business and keeps customer satisfaction happy without being way too expensive and not keeping your product in development too long. So there's a couple of options here, but I just wanted to paint the idea that it really is focused on how people make decisions. That's what I mean by a program. And so the maturity assessment it can be done just on that matrix. Is you take a look at the different rows, circle the ones that best describe your current program, your current projects that you're working on, how things happen, and what's the typical behavior. That could be a way to get a sense of that. Hand that sheet to like 4 or 5 other people across your organization and ask them to do the same thing. And then when you combine that, there may be some people that are more pessimistic and they'll score a little lower. There's some that are more optimistic, score a little bit higher. But in general, you're going to find a consensus as to what stage your organization is in. And so the idea then is to move your organization by improving how you make decisions, the information that's available, the estimates and predictions you make, the testing and accelerated testing, the use of the specific tools, how you do failure analysis and customer support, how those different rows then improve the weakest ones. Now, oftentimes that change will require changes in the program, how different parts of your organizations are sharing information and linked together. And for example, one of the easiest things is, well, what's the cost of a failure? We'll talk about that in a moment. All right. So one of the things that we do oftentimes within a project is say it's a computer. Maybe the computer that's in front of you, it has a screen, it's got some input devices, it's got a motherboard with the CPU on it, it may have some memory of some sort, either a solid state or a spinning disk. Let's say, and a power supply, everybody's favorite. One of the first things we're going to do is build a reliability model. And if nothing else, it's so we can set the goals for the product. Well, if the product's supposed to last, say, 95% should survive 1 year, that's a reliability probability and duration, and that's our system goal. Well, that's not usually fine enough detail for people to make decisions throughout the program. So we break it down in a block diagram so that the goal for the power supply and the input devices and the hard drive and so on are specific to them. So we call that apportionment. I think I've talked about that process in previous webinars. But the idea is that the goal should be something you can see, and it's going to take some work to get there. And so the intent is to provide signposts, basically, that allow us to get at achieving a business objective or a customer satisfaction objective, which is a business objective, to actually achieve our design that meets not only cost and time to market and functionality, but also meets the reliability aspects of our product or for this project. So the idea initially then is to compare our goals versus some reasonable estimates. And oftentimes we would want to use field data to do that. But it's not always around, right? Or it may be difficult to get our hands on. Now, what I really recommend you do is not use Mill Handbook 217 or a generic parts count database unless you absolutely have no option, right? If it's a brand new electronics to your organization and you have no history with it whatsoever, your engineering judgment should not be discounted. It's probably more accurate than a parts count database type approach. Parts counts do have a role. It's not in estimating field data. So I'll just leave it at that and try to get off of my soapbox. But as you develop the model, one of the best places to look, and the most common place for us to look, is our field data. Now, of course, startups making a brand new product don't have a lot of that information, yet we do have protos, and we probably get some betas out there, and we start gathering some very sparse information, which is a whole lot better than many other sources. Now, in most companies, we have a whole suite of products, and we have things that are very similar very often that are already in the field, and that provides wonderful data. Now, many of you already know that getting that information for the first time can be very difficult. It's not collected for reliability. It's collected for warranty. It's collected for customer support. It's collected for all kinds of reasons other than using it to estimate the field reliability of a product. So once we find the source of that data, it may take some work to actually make it useful. I suggest that you go through that and show how valuable that information is. That's this single piece of connecting your customer support or your customer-facing sides of your organization, your repair centers if you have them, back to your development teams is probably the single best way to move your organization from reactive to proactive. It provides a feedback loop. I think it was Rick that mentioned that earlier. It provides that once we made the decision to launch a product, that it was reliable enough that it actually is, or not. But it becomes that very useful information about, say, the power supply on our laptop or our desktop that gives us a sense of whether that's an issue for us or not, and that should take some engineering work to improve. But keep in mind that the field data is going to be noisy, yet it's closer to what we actually need than most anything else we do. So creating those links within your organization and then reinforcing it by how valuable that information is will just help you get to gather better and better information. Now, of course, some are already doing a great job at this, and some are not. But so just think for a second about where's this data exist for you, right? Where in your organization is it, and where can you go get it? And for the folks that have really good information, let me just ask the generic question: is it useful for you? You know, is it worth getting that information? If you use the chat window and let us know how important field data is back to your development teams. And if you're in a manufacturing environment, you're probably gathering data on your equipment. repair data, but how important is that when you design a new line? Yeah, and I agree, very important. Agreed. So getting very important, critical. Yeah, a couple other people are typing. It, it's a we could use all kinds of different ways of phrasing it, but if you're not using field data and, and you then what are you using? Right? How do you get the information you need in order to estimate what you need to work on for the program? Yeah. Oh yeah, Peter, exactly. It helps you define, what's something new. It is possible to be surprised in looking back at your program or the specific task within a project. How did you miss that? What are the things you can do to expand your coverage of what could go wrong? Those are great. Yeah, it's tedious, John. There's no doubt about that. Yet it it paints a picture that is in most cases impossible to get otherwise. Right? One of the things it does is it helps you to, yeah, started that even register on it. I haven't seen any negative ones or zeros on the matrix. I've seen some pretty bad companies, but I'll take your word for it. Yeah, that's great. It sounds like a success story there, Rick. Uh, yeah, and one of the things, if you go after only warranty data, one of the things I've done, or I've seen done, I should say, is where, yeah, we have to pay warranty. And so the finance people pay attention to that, and they're the ones funding that part of the project, and it might be tracked, is make sure that what they're counting includes the total cost of unreliability, or as much of it is relevant for your company. But use that number as a way to motivate changing your product. And I think it's one of my upcoming questions here is, what's the cost per unit shipped for your warranty? Now it's in the same unit of measure as the bill of materials, so that if I'm doing a cost reduction and I can save a nickel on a component, but the failure rate goes up by $1, I can balance those directly. So yeah, it's a way to use that data to your advantage to find the balance. But you have to massage that data into a form that makes sense for the development teams. Now, if you've been in any of my webinars before or seen much of my writing, I have this love-hate relationship with procurement, the folks that go buy the components on the bill of materials. Supporting a design team some years ago, the goal was to create a product that had a particular functionality. One of my favorite cases was working on an inkjet printer. And so the goal was to make a printer that would last for 5 years with a very low failure rate. And, the intent was to get people to buy ink over a long period of time, get them locked into that brand and that series of ink cartridges. Nothing devious about that. It was the business model. So the printer itself generally needed to be as inexpensive as possible because they didn't sell it at any great profit or anything. It often just broke even on the printer itself. But the procurement organization was charged with cost reduction. And you may have heard of this or seen it in your organization, where the procurement organization travels to all these different vendors. They work on making sure they can deliver the components. They work on troubleshooting issues. They do research on what new products are in the pipeline that may be useful for our future development. They do all kinds of cool and interesting things, but they're often driven by an overriding goal of a parts count cost, just BOM cost. And they may have a goal of 10% cost reduction year over year. It's very, very common. Depending on your program or product, it may be more or less than 10%, but it generally is based on just the idea of we can measure cost, and we do what we measure, and we're going to reduce costs. That's an objective for all of the discussions for the procurement organization. Now, we're reliability folks here, and we know that the lower cost part, initial purchase price cost, isn't always the right decision. It could reduce the reliability of your product, and then the cost of a failure of the overall system can be much, much higher. We know that. But how do you quantify that? How do you make it part of the discussion? Now, of course, we don't want to raise costs just carte blanche. We don't want to just say that's what we do, but we want it to balance what's the cost of failure. So one guideline I've seen over the years is that a cost of a system failure is 2.5 times its purchase price. Now, I believe that's more relevant for office products, consumer products. But what's your experience? What's your multiplier for your purchase price versus the cost of failure? What kind of numbers do you use, or what kind of numbers are common in your industry, I should say? I know like a server going down for eBay or for Amazon, if they lose that ability to take orders, it can be in the millions and millions of dollars per minute of lost revenue. Automobile factory knows that if the line stops, that's a vehicle that they can't sell, and they know how much lost revenue they have per minute of downtime on a production line. Do you have these? So, Greg, expand that a little bit. What do you mean by opportunity cost? I'm thinking of the actual cost back to the organization. If I do a warranty, and we probably don't investigate every failure, but we do put engineering effort into addressing field failures. It's going to cost more than just the one-to-one replacement. And I'm not even really going after the voice of the customer or the customer satisfaction numbers for lost sales, for example, if our products don't work, or if they work really well, we improve sales. Yeah, but I want numbers here, guys. What's your ratio of purchase price to cost of unreliability? How do you convince somebody that avoiding a failure or reducing failure rate is worth it? It's going to cost me $100,000 to improve the reliability of this printer. It better save some money overall. So how do I do a return on investment for improving the reliability? You're talking about some of the areas that are included in that, but has anybody got, or is 2.5 times the purchase price, is that a reasonable number for the cost of unreliability? Yeah, Rick, I've run into that in military organizations where you got a fixed price on purchasing, and if there's a failure, then you make profit in the repairs. I'm not talking about that business model, which I think is kind of perverse. 50% of total losses, yeah. So if you're in an organization where there's a cost pressure, and it's not including the cost of field failures, whether it's customer satisfaction, which is harder to measure, but in some organizations, they do the studies in marketing. Again, this is part of that program, right? Who knows how much it costs the customer when it fails? Who knows how much it costs the organization? That might be a finance part of the team. If you've got a whole group of engineers that are dealing with just field failures, they're not adding value. They're just shielding the engineering team from those failures. If there weren't failures, they wouldn't exist. There are costs of unreliability. So quantifying that is one way to then have your organization include the total cost. And you may have heard that before, the total cost of a product, the life cycle cost, the cost of ownership, those kinds of things. But it's a way to change the way procurement calculates the formula. So instead of forcing a 10% cost reduction and getting a less reliable set of components or materials, let's balance that out with actually understanding what's the ramification to the overall cost. Yeah. Yeah, and every business is different. I fully agree with that. Yeah, lots of good comments there. Thank you. So this is the question I alluded to earlier, is one of the things that helps design teams and procurement teams understand and recognize how reliability is part of the decision making they make is then use the metric of cost per unit shipped. So take your warranty cost or your cost of unreliability, your total cost, and divide it by the number of units you either shipped or you expect to ship. And that's like putting currency in the box when you ship it. And one time we calculated it for laptops, it was $200 for a $1,000 laptop. They weren't as reliable as they are today, but that realization allowed us to invest to reduce the $200 warranty cost, which was where we're at that time. Yeah, Greg, you're exactly right. For industrial products, the cost of failure can be pretty catastrophic, and I think IBM used to characterize it by when they had a server go down, they would fill the skies with white shirts and black ties and all kinds of pulling out all the stops to get the system back up and running. Very true. In one of my assessments, I was working with it was a consumer product, and I asked, so how would you rank order the importance to your development team of time to market, cost, reliability, and function? And she said, time to market, time to market, time to market. And we don't really think about the other ones. So because there were so many moving parts for a consumer product going into the holiday market, to get it right, to get production started early enough so you could get enough units on the shelves at the right times and the right locations so that the advertising, which was coordinated with the launch and the release, all would hit at the right time in order to maximize the return on the development of that particular product. Now, medical devices may have a critical conference, a doctor conference, where they're going to roll out that product. Startups really focus on Comdex. I think it's called Comdex. It's the CES, the Consumer Electronics Symposium or show. There may be an important date in your industry that then drives so many decisions. So this is different than the cost of warranty or the cost of failures that works with the procurement organization, but it's part of that interaction between a project and a program. So as the program is being developed and decisions are created and made based on, are we going to launch on time? Are we going to have the products on the shelf at the right time? What's our risk of delaying the program and the attendant costs to putting on hold all of these other activities? And you'll often hear it is that every day we lose sales if we don't launch on time, and then they can quantify that number. Well, what's the risk? How do we organize this across the organization is to say, at some point, this prototype, this new development is not good enough. But as a reliability engineer, we may not understand the failure rate. But working with our program managers and within our development team, what's that trip point? What's that criteria that says we have to delay the product? Right? Hopefully it's not a visual thermal event that the prototypes are dangerous and the early production just can't create products in any reasonable way that are safe. Hopefully it's not at that threshold, but as you think through, how do you quantify what's that trip point? When do you say, hey, we have to delay the program? And here's the justification. Here's the quantification of the risk that we're dealing with. So on the flip side, if your organization is being driven by time to market, then there is a risk of delay. But if I can find defects earlier in a program, we often use this, and I saw Kirk on the line, and I'm assuming that's my friend Kirk that does a lot of halt testing. And we've talked about it previously, is where the ability to find defects in your design earlier allows your team to address it. Finding it later, just before you go to market, and it causes you to delay shipment, is a real risk. So finding the defects earlier doesn't necessarily guarantee that you'll ship on time, but it reduces the risk of finding that 1 in 100 problem that will delay your shipment. So then you can do a cost benefit of this. Do I spend a prototype or two and find failures earlier in order to reduce the chance of delay, say by 1 or 2%? It may balance out just fine that it's a worthwhile investment. If you look at previous products in product development teams, how often do you delay and why? All right. So if I can reduce that delay by half, is it worth changing what we do? Would be one way to look at it. So loss of market share for early life failures. So if I know that I'm going to have a high defect rate, and we know what the cost per failure is, then I can quantify what's my impact, say, of the first 3 months of shipments of if I have a 10% defect rate, right? And say it's a $500 product, 2.5 times the purchase price for the cost of failure. That's 2.5 times 500 is not enough coffee this morning. It's $1,250 or $1,250, and that then times the 10% of my projected volume for 3 months, that starts to become a fairly large number. Now, if that number is not supported by our business objectives, if it would consume our profit with no long-term benefit, if it would destroy early reviews and customer satisfaction such that we don't get the word of mouth and the viral properties of marketing, then it starts to add up. But it's not typically reliability engineering a task to quantify that. Yet I found that oftentimes that's what we need to do. We need to think a little bit creatively about what's the impact of not meeting our reliability goals, and then highlight that to the decision makers and make it clear what the risk is. So let's say that we're not really sure we're going to get 10% failure rate. That's our expected projections based on our prototypes and testing. But we have a, say, 80% chance that it's going to be less than that. Say it's 5%. And there's some amount of chance that it would be larger than 10%. We'll quantify that. Say it. Here's the range what I expect it to be in. It could be here, it could be here, and here's the risk. Now, if we invest in minimizing that risk or that uncertainty, it'll cost us, say, $50,000. Is that worth it to reduce the risk of delaying the shipment or reduce the number of early failures? So it becomes a cost benefit, right? We don't need to be MBAs to think like that. But putting it in terms that the management team can understand, risk and money, then our reliability program then becomes part of their decision process. If I think Rick mentioned having a less than a stage 1 company, it's probably reliability wasn't even considered. It just happened to be a nuisance that occurred, and we have to deal with it when there's failures, and it's somebody's fault. It's not what we do. But as it becomes part of the business decision process, it tends to become more proactive. As we learn how to use the various tools and activities, as we master when and why we do FMEA or halt testing or accelerated testing, when do we pull out and use the research and using physics of failures and all the variety of other tools that we have available, then we move into a proactive stance. But it's not the reliability engineer alone that does that. It has to be part of the decision-making process throughout the organization, which is the program, the culture. The tools themselves have to be executed when they add most value. That's often what we have the most impact on, is when and why do we do particular activities? How do they add value to the organization and to the project? But when you put that together and you're looking at minimizing risk, that's when we're adding a lot of value back to the organization. Yeah. We don't need our, yeah, Rick. So I'm glad you guys moved on from that. It sounds like a wonderful place to work at. All right. So as you look at your own organization, whether you're dealing with cost or cost of delays or time to market or bill of material cost or inventing new functions as you continue to go, there's an ebook up on my site that the Ascendo site that's called Finding Value. And it has, I think, a dozen or so different ways to quantify the value of reliability activities. And registering the site, you can pick up that book for free. Now, if you don't want to register for the site, you can also find it up on Amazon. It's Finding Value, and I don't recall the subtitle at the moment, but if you look for that in my name, then you can find those ebooks. And let me know what you think of them. I still very much work in progress. That's why they're electronic format, so it allows me to change them pretty quickly. But let's take a look at these interactions, right? The idea of a project is to create a reliable product, create a solution for your customer. And that's not uncommon. That's what we're trying to do, whether in a manufacturing environment, a plant facility, or in a consumer product or any other product. The program that we work within provides a series of constraints. How many spares can we stock? What kind of capital investment do we have for say, failure analysis tools and so on? But the program that we deal in, the product life cycle and the design reviews and the capital equipment to go into developing solutions, those are part of decision making, and it's balanced on cost and risk. And so quantifying what we do as a reliability professional in those terms helps us to tailor our projects to best use the resources within the program. And then vice versa, identifies parts of the program that need improvement so that on a project we can meet the objectives. It really is how we make decisions across the organization. It's not what we do as a reliability professional. And to a large extent, as programs improve and grow in maturity, the decisions or the activities we do as a reliability professional focuses more and more on helping others make better decisions. So if you're looking at that maturity matrix and you're looking at how you can improve your lot as a reliability professional, to have more influence, to make better products, to help the organization meet customers' requirements, then take a look at how decisions are made. And that's what we're really after. So from that, then it's looking at that matrix and saying, well, what's the program elements? What's the infrastructure I need to get the data I need, to get the cost information we need, to understand the risks and quantify those, so that on the project, we can work to minimize the cost, minimize the delays, minimize the impact on customer satisfaction, whatever it is that's important to the organization. And it goes back and forth. So I put this slide in here because I wanted to mention that I'm in the process of putting this up online up on iTunes. It's a series of interviews that Tim Rogers and I have done, but not quite ready to go yet. So I think I'm tipping my hand a little bit in a head start. The interviews are available up on the Ascendo site. So if you get registered there, you can find these interviews. But a lot of other people have thought through a lot of what I've talked about today, and I'm pulling a lot of that information, and hopefully it came across and made a lot of sense for you. So, my spacing didn't work out on this one, but I think that means thanks for participating. And yeah, Greg, I get a lot of that. What we're doing and the information that we're looking for is often hidden. It's in the organization someplace, but it's there someplace, right? And it may take quite a bit of work to pull it out and put it in the shape we want. Yeah, Gene, I see your question on, does the matrix exist for continuous process industry? So I imagine you mean like oil and gas industry or a chemical plant. When you look at the assets that we're dealing with, the valves and pumps and various specific pieces of equipment, it's very similar to the matrix I have when you're looking at purchasing and maintaining assets. And a colleague has created a draft of that. What I really should do is get that posted and put up there. But I don't think we don't have one that I know of that works for the continuous process industry. The essence is the same. So if you feel like, feel free to take that matrix and tailor it to the language for how you make decisions in your own organization. How do you bring up a new line? How do you do a changeover? How do you analyze the data that you're collecting on your equipment? And then one of the criteria is what level of the organization is involved in making the reliability decisions. That's what I'm really after with the matrix. But good question. So I've got I think a couple of minutes here before the end of it, and I know many of you probably have other things you need to go off and do, and hopefully a couple or two ideas here from the discussion are parts of your to-do list in the next few days. And do let me know how it goes. Send me an email or drop me a line on LinkedIn. What's working, what's not working, and are these webinars helping you improve what you do? I'm curious to see how that works. And so I see a couple of folks online still, so I want to hang out for a few minutes and see if there's any questions. Yeah, and it's exactly right. The more we integrate what we do across the organization, and I know in my own career, sometimes it's been just fortuitous that I run into the right person, say from a finance group or from a marketing group, that can provide insights and information that helps the program that I'm working on. But there's nothing to say you can't go find those people. Go ask those questions and go track them down. Yeah, well, appreciate it all. Everybody's welcome. I'm happy to do these things. I enjoy it. I'm drawing a blank. I should make a note as to what my next presentation is, but it's going to be in the third week in June, a little bit off of my normal schedule because I'm going to be teaching at the University of Maryland for a couple of weeks, a reliability engineering management course, part of their graduate program out there. I look forward to that each summer. It's a lot of good students and a lot of fun with the discussions and applying many of these concepts we just talked about or I just mentioned in this presentation. It's a place to go. Yeah, Gene, maybe, let's trade some email on how to adopt the matrix and the process into your world, into the power plant world. I'm quite sure a lot of this applies. And you may be able to leverage some of the safety kinds of activities, which are generally more advanced than in many other industries. So you probably have a lot of the basic information already there, so we can build on that. Glad to be able to discuss it with you. All right, so I'm going to turn off the recording.